Sort and search in Python set number 10. Here is insertion sort. What is insertion sort? It works on the principle that pick an element and put it on its left side in the most suitable position. So, the work will begin from the second element because the first element is obviously on the best position. There is nothing on its left. So, from the second to the last, that means if there are 5 elements, then we will work for 4 times. If there are 10 elements, then we will work for 9 times, because for 9 elements, they need to be worked on. Then, look at the example and see how is this going on. We pick 25, look at its left. Yes, it needs to be shifted. So what we do is we take 25 out and shift 85. Shift, not swapping. We are not interchanging 25 and 85. We are shifting 85 to the right and putting 25 in the position where it is supposed to be. This algorithm involves right circular shift. Reason? Look at example in step number 2. Here you have got 10. Now when I take 10, this 10 needs to be inserted in this place. So 85 and 25 need to be shifted to the right. So see, 85 and 25 have been shifted and 10 is inserted. Then when it comes to 70, what happens is 70 is taken and is put on its position. Where is the position? You see, 70 is being compared to 10. It is bigger. So it's being compared to 25 is bigger. Now when the comparison between 70 and 85 is done, 70 is put in by shifting 85 to the right. Why I am saying shifting? Because when it comes to 60, you see 60 is being compared to 10 and then to 25. And when it gets compared to 70, we know here that 60 has to be put in here in this position, right? So in order to put 60 here, we need to shift this 85 and 70 to the right. So this insertion sort involves a right circular shift for the elements in the middle of the array. Like in this case, 60 is coming in by getting 85 and 70 shifted towards the right. And when it comes to 35, the last element in this list, you will understand better that this 35 can be brought in here. 35 being compared to the beginning. So from the beginning, one by one elements are being compared to, and wherever is the best position, there it is being put in by applying a right circular shift. If you look at 35, this 35 is coming to this position by finishing off its comparison with 10 and 25, and then this 85, 70 and 60 are getting a right shift. Okay, now comes the code. Here is the code, and in the code you can see the heading says insertion sort. The array is filled with random numbers. The array is printed in the very beginning, and on the right side here you can see the output already presented before you. So how is this insertion sort working? We take left position as 0 and for every element starting from position number 1. So we begin the work with this example. It says for 23. From 23 onwards, that means the first element. We take this position LP to indicate that on the left side it must begin comparisons from position number 0. So the element at position number P is being compared with all the elements on its left starting from 0, and as long as the current element is larger than the element on its left, the left position goes on increasing. That means if you consider something in the middle of it, like for this example, if you consider something like, this 67, so this 67 will get compared to 23, then 58. See, for 23 it is bigger, so the pointer LP will move ahead. Then with 58, which is the next position of LP, which like LP started with 0, then LP becomes 1. So 67 when compared to 58 will again make the left side pointer go ahead. When it comes to 68, that is the left pointer, then the element at the current position, which was 67 for this example, I need to bring it in here. So LP must stop here. So this LP here and P here makes the range of my right circular shift. So this is where this element at position P and this element at position LP needs to be circularly right shifted. That is what is happening here. LP is starting with 0. As long as the element in the current position is larger than the element on its left, the pointer keeps going ahead. Wherever the pointer stops, from there till P, I perform a right shift. Now this right shift code has to be separately done and understood by you. And insertion sort uses right shift for the elements wherever applicable. And hence, you will see in this example, each element is seen and is pushed inside in this. Like 32 is very well explained. When 32 is considered, it is being inserted in the position where it fits in. That means 58 to 75 gets a right shift. Need to be done once again for you to understand this thoroughly. Okay.